Alright guys, how we doing? So this is my first video on basically a playlist I'm hoping to do about covering some of the general topics, hopefully all of the general topics covered on the AP statistics exam, as well as for use in hopefully any introductory statistics course. So today I'm going to be skipping over maybe some of the more basic chapters on distributions. I will be talking about distributions in this section, of course, but I'm going to be skipping some of the basic characteristics of distributions as far as quantitative, qualitative data, and all of that is concerned. And I wanted to start with transforming data, okay, and specifically transforming data by addition and subtraction, okay, by adding constants of addition or subtraction, or also by imposing constants of multiplication or division. And we're going to find that this can be very useful in many practical areas of the real world, as is the case with most concepts in statistics. So I want to start by talking about and reflecting on how we characterize distributions. So we characterize distributions okay. We have essentially four main characterizations of distributions. We use the center, okay, which is like mean, median, sometimes potentially mode, probably not too much for our purposes, quartiles as well. So basically center is, the basics, right? We also have shape, right? Is the distribution symmetric? Is it skewed? Is it skewed to the left or right? We have spread. So measures of variability such as standard deviation, range come to mind. And then finally we have, kind of related to spread, we have outliers, right? So these are like the four key basic characteristics of distributions that we're concerned with, right? We want to know the mean of a distribution, the center of a distribution, generally speaking. We want to know how the distribution is shaped. We want to know how much variability there is between observations. And we want to know if there are any outliers. Okay, so that's the basics. And what we're going to be doing is we're going to be looking at distributions, and we're going to be talking about what happens to these measures when we add or subtract from each observation in the distribution, as well as when we multiply or divide from each observation in the distribution. Okay, sorry. So we'll start by talking about addition, right? So if I have a variable x, right? So addition, okay? So when we talk about addition, all right? So this is addition / subtraction, I should say, right? Because addition, subtraction, of course, subtraction is just the inverse of addition. So essentially they work in the same way, right? So adding or subtracting a constant A, we'll call it A, I'll put little quotes around it, okay? Adding or subtracting a constant A to all observations of a distribution or in a distribution. Okay? Adds or subtracts A, put it in quotes again, adds or subtracts A to measures of center and location. Okay, so essentially, if I have a distribution with some mean, okay, let's say I have a mean, we'll take a sample mean, we'll say that I have a mean x bar, okay, if I add A to all observations, okay, then the new mean, so new mean, I'll call it x bar sub A, okay, so the new x bar with A added to all observations, the new mean is going to be simply x bar plus A, okay. So essentially what this says mathematically is that you take a distribution with mean x bar, you add A to all observations, or I suppose subtract A, of course it'll have the same effect, just in the opposite direction. You add A to all observations, and so you add A to the sample mean. Now, this also applies, we said measures of center / location, okay? This will also apply to median, quartiles, and percentiles if you're concerning yourself with those, okay? So if you're looking at your quartiles from a distribution, those will also shift by A units to the left or right depending on whether you're adding or subtracting, okay? So simple enough. So let's just look at a basic example here, okay? Let's look at a really basic example. All right, so let's say I'm teaching a class and I have test scores, okay? So I have these test scores. Okay, and let's say these scores are out of 100 and I have the following scores. I'll just order them numerically. Okay, so we have a couple observations here. We can, of course, if we call the test scores, we'll call this the mean of test scores to be x bar, right? We can, of course, find x bar by adding all of these observations. All right, and I'll do that real quick. Over the number of observations, which is 8. Okay, and so I'll do that in my calculator real quick. You guys can do that as well. So we have 63 plus 67 is 130, plus 73 plus 75 plus 82 plus 82 plus 91 plus 93. Okay, divide that whole thing by 8, and we get a final result of an average score of 78.25. Okay, and let's say that, you know, I'm as a teacher, I'm not happy with these results, and I think that maybe I made the test a little bit too difficult, and I want to give some extra credit, maybe like a little bit of a curve, and so I decide, okay, we'll bump test scores up by 5 points, okay? So we'll bump the test scores up by 5 points. Now, we know that this new mean, we'll call this random variable now just y, okay? So I guess, well, we'll just actually, what I'll do is, because x bar is probably the better term to use, we'll just call this x bar 2. Okay, we know that if I'm going to bump this score by 5 points, what should my new mean be? Well, my new mean should be 83.25. Okay, if I take everybody's test scores and bump them up by 5, that should just bump the mean up by 5, essentially. Okay, and again, let's just show this for this example, right? If we take all of these terms, I'm just going to add 5 to all of them, right? Okay, so we'll have 68, 72, 78, 80, 87, 87, 96, and 98. Divide all of these by 2, or sorry, not 2, 8, obviously. And we'll go ahead and you can verify this. I'll do it with you guys. I'm just going to check to see that this, in fact, will equal just 83.25, right? So plus 87, plus 87, plus 96, plus 98, divide this whole thing by 8, and there you go, right? You guys can verify that, and this, of course, equals 83.25, okay? Let me move this up a little bit, okay? So as you guys can see, you know, I can go into a direct proof where, you know, we have many xi's, and we can prove this for any set of numbers. I can assure you that this is not just a coincidence for this arbitrary data set that I just pulled out of nowhere, right? This is true for any data set. So you can see that it's very simple to apply this transformation to the mean. You can see that my quartiles, right, if I go up here, well, first of all, what's my median, right? So my median is, if I go back up to my original data set, it's the point between 75 and 82, right, which is 78.5, okay? You'll notice that my median should also be bumped up by 5 units, right, because we're adding 5 points. So if I go and look for my median between 80 and 87.5, that's, of course, 83.5, and you can see that the difference between these two medians is also exactly 5 points, right, for the 5-point adjustment that I made to this course. So addition, subtraction, very direct transformation to distributions, right? It just changes the center, changes measures of location, right? If you want to, you know, take it one step further, look at the Q1 and Q3. Q1, of course, is going to be 70 over here. If you look here, Q2 or Q1 over here is going to be 75, right? The number between 72 and 78. Okay, and then of course this will be the same thing. So I'll label this Q1, label this Q1. Okay, and then again, if you look here as well, midpoint between 87 and 96, that's going to be 91.5. If you look at the midpoint between 82 and 91, that's going to be 86.5. And again, you observe a 5-point difference. So any measures of location, the ones we're of course most concerned with are measures of center, but any measure of location is going to be adjusted by this constant of addition. Okay, and so this video has gone on for about 12 minutes, so I'm going to cut it off here, and I'm going to start the multiplication section. I'll go through it a little bit faster, but I'll start that in the next video. Okay.